Hello, so today's lesson is about spheres and cones. We're going to be calculating the surface areas of spheres and cones. Our starter though is about enlargements and scale factors of similar shapes. So A and B are similar rectangles, and B is an enlargement of A by a linear scale factor of 2. So we've got 3 jobs. We're being asked to find the missing dimensions of B, the area of each of the rectangles, and finding out how much bigger rectangle B is. So while you're working on that, pause the tape. Okay, so welcome back. So we've got our linear scale factor is 2. So that means these lengths are twice the size in this rectangle. So 8 times 2 is obviously 16. 5 times 2 is 10. That was easy. So then the area of each triangle, so the area of A is 5 times 10. No, it isn't. 5 times 8, which is 40 centimeters squared. And the area of B is 10 times 16, which is 160 centimeters squared. We've done that bit. So this thing here is really asking for our area scale factor. So what would we have to multiply 40 by to get to 160? So we would have to obviously multiply that by 4. So B is 4 times bigger. Right, so let's have a look at the formulas now. So firstly, we've got the surface area of a sphere with the radius r. The surface area is 4 times pi times the square of the radius. You might want to write that in shorthand as leaving out those multiplication signs. 4 pi r squared. And the same goes for the cone here. So the reason the cone is in 2 parts is this section here is for the curved section. So this, if we imagine this cone was sat on a table, the bit that you could see, and this part here is for the base. To calculate them separately, then add them together. So we might want to change that, as I say, to pi r L plus pi r squared. So for the challenge question later on, you might want to remember that this part here is relating to the curved section of the cone. So let's have a look at a couple of examples. So side heading examples. So here's our first one. So we've got our formula here. We're just going to put that, rewrite it by putting in the actual values. So obviously the 4 and the pi don't change. But now instead of r, I'm going to write down 8. So I'm going to put that into my calculator now. So make sure you've got your scientific calculator. So I've got 4 times pi times 8 squared So you may have an answer of 256 pi, right? That's correct, but we want it in just ordinary numbers. So just press your SE button and you're going to end up with an answer of 804.2 centimeters squared, because we had our radius in centimeters, the area is going to be in centimeters squared. So let's just look at our second example now. Right, so we haven't been given the diameter, the radius here, we've been given the diameter, but we need to understand that the radius is half of the diameter. So that is 10 divided by 2, so it's 5. So the same thing, just going to rewrite the formula we use in the actual dimensions. And then our second job now is put those figures into our calculator. So I got 4 times pi times 5 squared. So I've got 100 pi, which is 314.2, again, centimeters squared. Right, so let's look at our cone examples now. So our first job again is just to write this out using our actual figures. So we've got pi times a radius of 3 and our slant height of 5 plus pi times 3 squared. So with this, being this is in 2 parts, to make things easier for ourselves, we should first calculate what each of those brackets is, just in terms of pi. So I can see I've got 3 times 5, which is 15. So I've got 15 pi here. Then here I've got 3 squared, which is 9. So I've got 9 pi. Then 15 times 9 is obviously 24. And now is the first time I need to think about using my calculator. So just put in 24 pi. And using my SD button, then I get an answer of 75.4. And we've got lengths in centimeters again. So we've got our area is in centimeters squared. So here's our last example now. So again, just rewrite the formula by putting in our actual numbers. So we've got pi multiplied by r, which is 4, times the slant height of 7, plus pi times 4 squared. So let's work these out in terms of pi first. So 4 times 7 is obviously 28. So we've got 28 pi. 4 squared is obviously 16. So we've got 16 pi. So if we just add up 28 and 14, not 14, 28 and 16, we'd end up with 44. So we have 44 pi. And now It's the first time we need to use our calculator. And we've got a answer here of 138. Point 2. Again, length in centimeters, so area in centimeters squared. So here we go. So our main task is separated into 3 parts. We've got the first part is just spheres, the second part is just cones, and then the third part is a challenge question. So pause the tape while you're working on each section, and then we'll come back at the end and have a look at our answers. So here's our first part, which is just spheres. Remember, just to 1 decimal place. Here's our second part now, which is just cones. Again, 1 decimal place. If you notice E and F, you don't have all the information that you need straight away. Remember, we need the slant height and the radius, but if we recognize that, so pardon my drawings are not great because I can't use a ruler with this. If we imagine this height of our cone and our radius of our cone, and this here are slant height or slant length of our cone, this would actually be a right angle triangle. The height is obviously the vertical height. So you need to do a little bit of work before you can actually use the formula. Okay, and then here we've got our challenge question. So you might want to bear in mind what we said about the 2 parts of the cone formula for this part. And then when you're ready, we will have a look at the answers. Okay, so marking your own, here's the answers to the first 2 parts of the main task. And we'll have a look at the challenge. Okay, so let's have a look at this challenge question now. A lot going on here. So if you think about this this shape here, it's split into 2 parts. We've got a hemisphere here, or half the sphere, and we've got this cone sat on top of it. So that's relatively straightforward, the hemisphere. We'll come back to that in a moment. But let's just look at the cone first. So we don't need to worry about the base of the cone because there is no base because it's actually attached to the hemisphere. So we can just think about the curved section. But firstly, we know that we need to find that length there, our slant height or slant length. And we would do that by recognizing that our height and our radius and our slant height or slant length make up a right angle triangle. So I need to find out what this is first. So let's have a look at the hemisphere part. So the radius of 3 is also the distance from here to here. So our height must be 10 minus 3, which is 7. So thinking about Pythagoras, we'd know that L squared is 3 squared plus 7 squared, which is 9 plus 49, which is 58. So L must be the square root of 58. I'm going to just leave that as the square root of 58 for the moment. It'll make things a little bit easier going forward. So we're going to call that section A, aren't we? So the surface area of section A, remember our curved section is just pi times r times our our height, length height, or like slant height is what I'm trying to say, isn't it? So root 58. Okay, so I'm going to just leave that as it is for the moment. And then B, instead of 4 pi r cubed, we know it's going to be half of that. So we can just say we've got 2 times pi times 3 squared. So our total, right, so we've got 3 pi root 58 plus 3 times 3 is 9 plus 18 pi. And then we can just put that into our calculator now as it is. So we've got 3 pi multiplied by root of 58 equals, then plus 18 pi. And then we get our final answer of 128.3. Again, length in centimeters, so our area is in centimeters squared. So if you've got that, that's really well done, because that was a bit of a stinker question. So side heading now, checking question. So we want the surface area of this hemisphere. So if we think about our surface area, we need again to think about it in 2 parts, because we'd have this area here, the area of this circular section, and our area of our curved section, which is going to be half of the normal sphere surface area. So A, we know that is pi times r squared. So we've got 49 pi. And then B, instead of 4 pi r squared, we've got 2 pi r squared. So we have got my mind's gone blank all of a sudden, 98 pi. So just do that in my calculator now. So my total is going to be 47 pi plus 98 pi. 49 pi even. Which is 461 0.8 centimeters squared. Okay, well, thank you very much, and I will